Hello everyone, welcome to another video, and today I'll be showing you a problem about an arithmetic sequence combined into an algebraic trigonometric simplification problem. And for this problem you would want to know the formula for the sine double angle theorem and the sine and cosine addition and subtraction theorem as well. Okay, so let's get started. So un is just like an expression for an arithmetic sequence, has two terms from it chosen at random, which is -1 and 54. And we know that there are 10 terms in between these two terms, so there's 10 terms in between -1 and 54 in the arithmetic sequence un. Okay, and then given that information, we need to evaluate this long expression over here, and in degrees. Okay, so first thing I would want to do is I want to try simplifying this expression a little bit, and then let's see what we get from there. Okay, so we have sine 2 sine 3un times cosine 3un minus 1 minus cosine 3un sine 3un minus 1 cosine times cosine 3un cosine 3un minus 1 plus sine un times sine un minus 1. If you look at these terms over here in the middle, specifically this part over here, right here, represents this part, this formula right here, and we can see that a and b in our cases will be 3un and 3un minus 1. So if we say a is equal to 3un and b is equal to 3un minus 1, we will be able to see that this thing simplifies into these formulas right here. Okay, so let's try that. If we say 2 sine a cosine b, let's make sure we include the parentheses, minus cosine a sine b times cosine a cosine b plus sine a sine b. Now we can see that there's clearly a connection between this and this up to here and these two formulas right here. This first parentheses matches clearly with the sine a minus b formula. So we know that sine a minus b is equal to, because we chose a minus over here, we will also choose the minus down here. So we know that this is equal to sine a cosine b minus cosine a sine b. Okay, so that is matching exactly with what we have over here. But what about this one now? We can see that it's cosine a cosine b plus sine a sine b. So we have cosine a cosine b minus sine a sine b over here, but that's for when you do cos a plus b. When you choose cosine a minus b, it'll become cosine a cosine b plus sine a sine b, which is exactly what we want. So we want to use, that's cosine a plus, no, sorry, minus b. And it's equal to this thing right here. Okay, so let's substitute that. We have 2 sine a minus b cosine a minus b. Okay, now finally we can use this double angle theorem and say that, let's say theta is equal to a minus b. If theta equals a minus b, we will have 2 sine theta cosine theta, and we can change that into sine to theta. Nice. Now what we can do is we can now plug in back to what we had over here, and we can get that sine to a minus b, and then we know a and b are specific they're also variables that we can substitute in. We can say sine 2 3un minus 3un minus 1. So this. Okay, that's good. Now, wait, we can also factor out this 3. Let's do that real quick, just to make it a little bit more simpler. We can say sine 2 times 3 un minus 1. 2 times 3 is just 6. It's just 6. Nice. Okay. So now this is our expression that we have to we will evaluate at the end. But we don't know what un minus 1 is, right? Well, that's because we haven't used the first part of the question, which says that which is about the arithmetic sequence. And what we want from the arithmetic sequence is the difference, because if you see this, any nth term minus the term behind it, because this is what this essentially means. It means the nth term minus the term before that is equal to the difference of the arithmetic sequence. So if we find the difference of this arithmetic sequence, we can plug that in for the value of un minus 1. Now, how do we find the difference? Well, we know two of the terms, -1 and then 54, and we know that there are 10 terms over here in between them. So what we can do to figure this out is that we know that there will be 11 terms between, not between, but 11 terms from -1 to 54, and that is because when you have terms in between two numbers, you have to count the jump from the outside term to the 10 between numbers, and then you get to the 54, which will give you one more than the amount of terms that are in between. To better show this, we can just start with an example, like a really easy example, like 2, 3, 4, 5. There are 2 terms in between this, and in between 2 and 5, but there's 3 jumps, 1, 2, 3. And this goes for anything. It's just a counting principle. So we know that there's 11 jumps, or 11 times 11 differences being applied in between -1 and 54. So we can say that the difference between -1 and 54 is 55, because 54 minus 1 is just 55. And we know that there's a difference of 11 times the difference. So then we can just say that the difference is 5. And then because we know the difference is 5 now, we can backtrack to what I said earlier, which is that we can replace un minus 1 to d, and then d is 5, so then we can put d right here, which will give us sine of 6 times 5, which will just be sine 30, and sine 30 is 1/2. Alright, thank you guys for listening, and feel free to ask in the comment section what questions you have or your own ways of solving this.